Hello everyone, this is Naveen Kumar from IIRA College and my roll number is 21955A2106 from Aeronautical Engineering. And today my topic is about start delay and leading edge section for a pitching airfoil with trailing edge flap in automatic in avionics and instrumentation subject. First of all, we'll discuss about what is stall delay. Stall delay and leading edge sections are two aerodynamic concepts which are related to the behavior of airfoils and the particularly in the context of aviation. Let's break down each terms and we'll discuss about the stall delay. Stall delay refers to the sudden loss of lift that occurs when the airfoil, such as an aircraft wing, exceeds its critical angle of attack. And the critical angle of attack is the angle between the chord line and the imaginary line from the leading edge to the trailing edge of the airfoil is called chord line and the oncoming air. Let's discuss about the causes of stall delay. And here we have the causes of stall delay is a desirable phenomenon where the onset of delayed to the higher angle of attacks. Then, then we would typically be expected. It allows an aircraft to operate at higher angle of attack without experiencing a stall. Next, we'll discuss about methods to achieve stall delay. The methods of achieving stall delays are one of the methods are leading edge devices and wing design. Here we discuss about leading edge devices. Leading edge devices are like slats and leading edge flaps can be deployed to change the aerodynamic characteristics of wing and delay the stall. Whereas come to wing design, here wing design is also one of the active methods to achieve the stall delay. And in this wing design, the airfoil shapes and the wing designs are optimized to naturally exhibit stall delay characteristics. Here we have a flow over airfoil. Generally, the stall will occurs over a airfoil when the angle of attack is increased. So here in this picture, we can see that the flow with the angle of attack at 6 degrees. There is no separation of flow and there is no occurrence of stall. Whereas come to here 15 degrees, it is the place, it is the angle of attack where the maximum CL value will occur. And here we can see some of at the trailing edge, we can see some of the separated flow over an airfoil. Whereas come to 25 degrees here we can surely we can get we can observe the choice of getting it stalled where 25 degrees is the maximum or not maximum. It is a stalled angle. Whereas coming to the leading edge section is also one of the stall delay method where we can see briefly about this leading edge section. Leading edge section is a term which is used to describe the low pressure region that develops on the upper surface of airfoil near the leading edge when the airfoil is generating lift. It has come to roll in stall delay. These reeling edge section will plays a major role in delaying the stall. So here by optimizing the airfoil shape and incorporating the leading edge devices, leading edge section can be manipulated to delay the onset of stall. Whereas Coming to other point, there the low pressure on the upper surface helps to keep the boundary layers attached to the airfoil by delaying the separated airfoils. Here we can see the picture of leading edge section. Here it is the leading edge and it is the trailing edge. And here the upper surface is about lower pressure. The like down surface is with high pressure. Here the um, section of some external free stream velocity will helps to reduce the stall delay, and it will reduce the increasing effect of stall. This is about the leading edge section. Whereas coming to this trailing edge section, trailing edge flap is also one of the method to delay the stall. And in this method, we'll discuss over here. A trailing edge flap is a movable controllable control surface on the trailing edge of an aircraft wing. It is lowered or raised to change the camber and the lift characteristics of the wing. Roll in stall delay. Trailing edge flaps are commonly used to increase and decrease the stalling speed of an aircraft. And by deploying the flaps, the effective camber of an airfoil is increased and allowing the aircraft to operate at a higher angle of attack before experiencing the stall. And here we have seen the three types of stall delay methods. One is the stall delay, and another one leading edge devices and wing design, and these leading edge suction and this trailing edge flap. These are the majority of stall delay will occur methods are used. And here the trailing edge flaps. Here we can see the some of the pictures of trailing edge flaps. Here the basic airfoil section, which has the trailing edge flap. One of the different types of flaps are like plain flap and split flap and the Fowler flap and the slotted flap. Here we can see plain flap is only like a small airfoil, whereas come to split flap, it will split from the airfoil section. Whereas coming to the Fowler flap is attached to at the end of tip of the Fowler flap. Whereas come to this slotted, here we can see some of slot is between the leading edge section and the trailing edge section in the middle. Like here we can see the some of the pictures of different types of flaps and their deflections. How the deflected flaps can increase the CL value and delays the stall. Here we can see the CL values and alpha values, how they are varying with the these flaps deflections. These can delay the stalls. In the conclusion, in the summary, the combination of leading edge devices, airfoil design, trailing edge flaps are employed to achieve stall delay pitching airfoils. These techniques are crucial for improving the overall performance and safety of aircraft, allowing them to operate effectively at varying flight conditions. And thank you.